Okay, today's lecture won't be long. I'll just talk about some of the things that I was not able to cover last time. Not too many from the lectures tutorial, and so there will be something due tomorrow, right? Wednesday is going to be the lab, and Thursday will be another homework 2 will be due on that day as well.
What's the
Lab, yeah. Oh, you already did it. You already submitted.
Oh, okay.
Yeah, lab 2. Yes, yeah. That's right. Yeah. So before I talk about all the stuff I have to cover, do you have any questions on anything like FPGAs, tools, schedule, and?
Oh, when we were doing the program memory thing, I don't totally remember what it was called, where you have to like switch the jumper and then it like holds the program on the board. You have to select the device in Vivado.
Mm-hmm.
The device that was listed didn't work for me, but it like said devices don't match, try this one instead. I tried that one, it was completely different and it worked.
Which style? Let's take a look at it.
It might have been the first lab, or no, it's the second lab. Okay.
I mean, so it's the step when you have to select the memory chip, or?
Yes, yeah, exactly.
Here?
Farther down. It's like right at the bottom, or close to the bottom. A couple more. That one. Add configuration.
So you don't have this one?
I had that one, selected it, it said it didn't match with the board, and said like try this one instead. I entered the one that it told me to try and it worked.
It's a newer version of the Basis 3 probably. They have to replace the memory chip on it. Interesting. But if you flip it on the back, you can see the print on the top of the chip actually. So if you look at that one, see if it's just matching the name in the tool. It probably won't be this one anymore. Okay. Okay. So I just graded the homework 1 and the lab 1, and for most of you did pretty well and make it clear. But if you didn't add any comments on it, please do so. It's because it's a report. It's not a picture show, right? So you want to explain the results a little bit and just describe it slightly. I'm not expecting super long text, but
whenever we insert an image, aside from just putting like the figure and the description on it, should we do a little explanation of what's happening, just like on every image?
Yeah.
Okay.
And there's another example for the non-blocking and blocking. Okay, so if you just run the simulation, I won't be able to tell what's going on, right? And I think the results looks different from this one, but the results are being combined into a data bus, so it's not showing every single bit. And just by looking at the simulation, you won't be able to tell which bit is showing which data on it. So if you can click it to expand all the bits, so you can show the bits, the digital numbers in there, I can also tell. Or you just explain it, like for this data bus, I have these bits in there, which is different from the other 3 bits combined, because it's blocking and non-blocking. They are doing different, assigning different numbers to the values, right? Let me see if I have an example of the. I don't have any of the bus being showed here, so it's all single digit. So if you click it, you will be able to show all the single bits instead of a bus, a bundle of all the digital lines. That's another comment here. Let me see. All right, so for this one due Thursday, okay, so take a look at the tasks. I think we were talking about the digital design, pretty simple modules, the home alarm module with a module and test bench. And after that is a parking digital safe system, which is a password matching system. I think you guys were trying to program it last Tuesday. it should be pretty simple, okay? So if you look at the code here, here's a module, you have to use a switch and LED, right? And for the, oh, that's the test bench, right? So that's the digital block. So where do we get, where this came from, this logic expression?
Because when they're different, you want it to pass a 1 because then that gets, or pass a 0.
Yeah, because this is a circuit, right?
0.
So this code is exactly the circuit of this schematic. Okay, you don't have to redesign anything. It's just looking at every single gate. So which structure modeling method is this? Just to remember? No, if you use a sign, it's that's a data flow, right? It's a data flow modeling method. Okay. All right, I don't think there's any issues here. This should be pretty straightforward. Implement it onto the IPGA board, and you should be able to toggle the switches and show the results. Any questions for this module? It's probably the first IPGA program you are going to implement onto the board. Any questions or anything? No? Everybody's good on this? Cool. So for the car parking, occupied spots counting system. So showing the customer that how many parking spots still available. You probably have seen some of the optical detectors on the top of the parking spot, right? So if there's a car blocking the optical signal, then it's probably receiving a reflection to the laser, to the detector, and then it's reporting a 1 or 0, showing a different signal, showing a green or red dot. So, but this is just a circuit, the main circuit block of it. It's not connecting to any LEDs. So if you look at the design, inputs are S0, S1, S2. And if you list all the possibilities for the 3-bit binary number, there are 8 different options. Okay. And these are the outputs. These are the inputs, outputs for the digital block. Okay. So if you just look at the 0, 0, 0, do I have to put a 0 here, 0, 0 here for this application? So if this is a parking spot counting system, okay, so these inputs are from where? Where are these inputs come from?
Parking spots.
The parking spot sensor, right? Yeah. So if none of the sensors are reporting, are not counting anything, it should be exactly 0, 0, because that's a count, exactly the count of the output. Okay, if it's a 1, you put a 1 here, right? And that's not correct. Why? No, I was giving you a different example. So why it's not correct? I mean, this is a very simple decoder example. I don't know if this will remind you about the decoder. So all the 3 inputs are just a code input, and then you have to output something, right? So if it's a decoder example, we have to exactly using the numerical number of the input as output.
Can you rephrase that?
I know, yeah.
That was confusing.
Okay. So for a decoder, right? This is a decoder. So the left 3 columns are inputs and the right 2 columns are outputs. Okay. Do you have to do like, if the numerical number, for example, is a 0 for the input, do you have to output a 0?
Not necessarily.
Yeah, yeah. So for example, if you look at the other examples down at the bottom over there, so the input is 1, 1, it's 8, right? No, it's 7, right?
Which one? Which column is it?
No, the bottom column is 7, but you are outputting something else. So these are actually individual sensors output. If there's a 1 getting flipped, you got a 1 occupy, right? So you're not actually using that number. It's just a 1 digit. So yeah, it's adding ones, but it's not a binary number combined, right? So this one 0, this one got a 1. So if it's 0, then it's occupied, right? If it's a 1, then it's available, right? But is this a number or it's just a different digits? What is this? 1, 1, 3. Yeah, that's right. Got a 3 available spots, right? So that's a decoder design for the combinational logic. So when you design that output, so it should start from the truth table, right? Which one you want to start with to converting the truth table to a combinational logic circuit? So after truth table, what's the next? Are we supposed to look at the one single column, right? So look at this column and look at the ones. So here 1, 2, 3, 4. You got 4 ones, and for this one you have S0 bar, S1, and S2. Okay, that's the mean term. And you want to OR with this, this, and this to get C0. Okay, similar concept for C1 as well. And translate it into the Verilog script and put in Vim and import it to your Vivado and implement it on the IPGA board. So I think this is also very straightforward. Okay, I don't think you really need me on that. You guys are super smart. Nobody's listening, so it's okay. Too simple, I think. It's too easy, simple. But there's one thing I want to talk about that, which is number 4. So for number 1, 2, 3, you can see all the resources from the website. But number 4 is an open topic. You are going to design a digital system similar to these ones, the parking system, the safety system, and the first one is the room alarm system, something similar. Okay, just combinational logic, but it has to be attached to a certain application. So you are going to explain what this system is being used for, and design write the Verilog code and implement to IPG and do the demonstration using switch and LEDs. You can also use push buttons. It's very similar, but make sure that the push button part of the constraint file is getting uncommented, so they are available for the synthesis when it's generating the bit file. Okay, that clear? Okay, so I'm gonna do the quiz. I think the 3 of you didn't. Oh, Anders is here. So 3 of you didn't do it. And if any of you guys did it last week, you want to redo it, I will let you do it, because only if you want to do it again. All right. There are allowing other people to do it this week. It's got longer time to practice. Just want to make it fire. Okay. If you want to redo it, get a better grade, you can still do it. All right.
We get to know our grade and whether or not we did good on it before we sign up to redo it.
I can let you know, or you can come over and ask me.
Okay.
Yeah. You don't have to redo it.
Okay. I didn't want to redo it if I did well on it and then do worse. Forgot. Well, the very me thing to do is be like, yeah, I'll redo it, and then get half the score I got the first time.
So there will be a lab on Thursday, and if you go back to the lab's webpage, you should refresh it. If you're still seeing a lot of other labs available there, please refresh the browser, because I'm trying to update the materials in here a little bit. It's being used for 2 to 3 years. I want to adding some new things to it, make it more fun. But it's going to be available on Wednesday. Okay. yeah, I think that's it. That's what I want to talk about. So today for the rest of the class, you guys should work on whatever has to be submitted on Wednesday or Thursday, either the lab or the homework 2. Okay, if you haven't done that yet, and you should run the simulations or upload the code to the IPG and demonstrate it to me. If you want to stay here, and so you can you can get help from me. If you really want to work at home, it's okay. You can do it in the lab or do it somewhere else. No problem. So let's do the quiz first. Okay.